Hi everyone, welcome back to this video series on Windows Server 2016, virtualizing your data center with Hyper-V. I've always been a country boy, driving dirt roads, working on cars, and tend to fill my free time. Traveling to cities, and particularly a recent trip to Hong Kong, always hits me with a bit of culture shock. All those skyscrapers and tall apartment buildings serve an important purpose, though, and serve to fulfill my metaphor. If there isn't enough land to grow outward, then you have to build up. The vertical ascension of large cities is similar to what has been happening in our data centers over the past 5 years. Cities need more and more places for people and businesses, just like we need to house more and more servers each year. Rather than horizontal expansion with enormous server rooms filled with racks and racks of hardware, we are embracing the skyscraper mentality and virtualizing everything. We build considerably fewer servers and make them incredibly powerful. Then on top of these supercomputers, we run dozens, if not hundreds of virtual servers. The technology that provides this hypervisor layer, the ability to run VMs, is Microsoft-centric shops, is the Hyper-V role in Windows Server. This is one of the most critical roles to understand as a server administrator. Because if your organization is not yet making use of server virtualization, trust me when I say they will be soon. Virtualization is the way of the future. Here are some of the topics we're going to explore so you can become familiar with the virtualization capabilities provided by Microsoft in Windows Server 2016, designing and implementing your Hyper-V server using virtual switches, implement a new virtual server, managing a virtual server, shielded VMs, Hyper-V Server 2016. Designing and implementing your Hyper-V server. Creating your own Hyper-V server is usually pretty simple. Build a server, install the Hyper-V role, and you're ready to get started. In fact, you can even install the Hyper-V role right onto a Windows 10 Pro or Enterprise computer if you need to run some virtual machines from your own desktop. While most hardware that is being created these days fully supports the idea of being a hypervisor provider, some of you may try installing the Hyper-V role only to end up with the following error message. This means one of two things. Either my CPU really doesn't support virtualization, or I simply have some settings turned off inside the BIOS on my server that are preventing this from working. There are three considerations you should check into on your server to make sure it is ready to run Hyper-V. First, you need to be running an x64-based processor. This kind of a given since Windows Server 2016 only comes in 64-bit anyway. If you don't have an x64 processor, you're not going to be able to install the operating system in the first place. Second, your CPUs need to be capable of hardware-assisted virtualization. This is typically called either Intel virtualization technology, Intel VT, or AMD virtualization, AMDV. And last but not least, you must have data execution prevention, DEP, available and enabled on your system. If you have investigated the hardware itself and it seems to be virtualization capable but still not working, then it is likely you have DEP currently disabled inside the BIOS of that system. Boot into the BIOS settings and enable DEP as long as your processors are happy to run virtual machines. You can turn just about any size of hardware into a hypervisor by installing the Hyper-V role. It is not important to think about minimum system requirements because you want your system hardware to be as large as possible in a Hyper-V server. The more CPU cores, RAM, and hardware drive space you can provide, the more virtual machines you'll be able to run. Even the smallest Hyper-V servers I have seen in production environments are running hardware like dual Xeon processors, 96 gigs of RAM, and many terabytes of storage space. While 96 gig of RAM may seem like a lot if your standard server build used to include 8 gig of RAM, which is a pretty low number. And if you want to run dozens of servers on your Hyper-V server, you are already past the capabilities of a Hyper-V server with only 96 gigs of RAM. 8 times 12 is 96, and you haven't left any memory for the host operating system to use. Installing the Hyper-V role. Hyper-V is just another role in Windows Server 2016, but during the installation of that role, you will be asked a few questions, and it's important to understand what they're asking so that you can be sure your new Hyper-V server is built to last and to work in an efficient manner. First of all, you will of course need to have Windows Server 2016 already installed and use the add roles feature function in order to install the role called Hyper-V. As you continue walking through the wizard to install the role, you come across a screen labeled Create Virtual Switches. We will discuss networking within Hyper-V a little bit more in the next section of this chapter, but what is important here is that you get to define which of your server's physical NICs will be tied into Hyper-V and available for your virtual machine to use. It is a good idea for each Hyper-V server to have multiple NICs. You want one NIC dedicated to the host itself, and you want, which you would not select in the screen. Leave that one alone for the hypervisor's own communications. In addition to that NIC, you will want at least one network card that can bridge the VMs into the corporate network. This one you would select, and you can see in the upcoming screenshot if you will be hosting many different VMs on this server and they need to be connected to different physical networks. You might have to install many different NICs onto your Hyper-V server. After defining NICs, we get to decide whether or not this Hyper-V server will be able to handle live migration of virtual machines. Live virtual machine migration is the ability to move a VM from one Hyper-V host to another without any interruption of service on that VM. As you can see in the screenshot, there are a couple of different ways you can set up the server to prepare it for handling live migrations. And take note of the text at the bottom that is telling you to leave this option alone for now. If you plan to make this Hyper-V server part of a cluster, in cluster environments, these settings are handled at a different layer. The last screen that I wanted to point out is the definition of storage locations for your virtual machine data. After creating VMs and digging into what they look like at the hard disk level, in other words, when you look to see what files are created per VM, you will see that there are two key aspects to a virtual machine. First is the virtual hard disk file VHD or VHDX, and second is a folder containing configuration files for that VM. As you can see in the upcoming screenshot, the default locations for storing these items are something you would expect out of a client application you were installing onto a laptop, but you wouldn't expect something as heavy as Hyper-V to be storing its core files into my documents. I suppose since Microsoft doesn't know the configuration of your server, they can't make any real guesses as to where you really want to store the data. So they set the default to be something that would stand out as strange so that you would change it. Many Hyper-V servers will have dedicated storage, even if only a separate hard disk on which these files are planned to be stored. Make sure you take a minute on this screen and change the default storage locations of your VMs. Using virtual switches, upon completion of the Hyper-V role installation, your first inclination may be to jump right in and start creating VMs. But first, you should really take a minute and make sure that the networking capabilities of your Hyper-V server are adequate to meet your needs. During the role installation process, we selected the physical NICs, which are to be passed through into Hyper-V, and that screen told us it was going to establish a virtual switch for each of these NICs. But what does that look like inside the console, and what options do we have for establishing networking between our virtual machines? In order to answer these questions, we need to open up the management interface for Hyper-V. As with any administrative tool of a Windows role, check inside the Tools menu of the Server Manager, and now that the role has been installed, you will see a new listing for the Hyper-V Manager. Launch that, and we are now looking at the primary platform from which you will be managing and manipulating every aspect of your Hyper-V environment. We currently have a lot of blank space in this console because we don't have any VMs running yet. Over on the right side of the Hyper-V Manager, you can see a link that says Virtual Switch Manager. Go ahead, click on that link to be taken into the settings of our virtual switches and networking. Towards the left, you will see the current list of virtual switches. On my server, there is only one switch listed there at the moment, which is named according to the physical NIC to which it is connected. This is that virtual switch which the role installation process created for us when we created the NIC to be included with Hyper-V. If you selected multiple NICs during the role installation, you will have multiple virtual switches available here, each corresponding to a single physical NIC. Every VM that you create will have one or more virtual NICs, and you will see shortly that you have the ability to choose where each of those virtual NICs gets connected. If there are 5 different physical networks that your VMs might need to contact, you can use 5 physical NICs in the Hyper-V server, plug each one into a different network, and have 5 virtual switches here in the console so that your VM NICs can be plugged into. As you can see in the previous screenshot, we have a button named Create Virtual Switch, which is self-explanatory. Obviously, this is where we go to create new switches, but there are 3 different types of switches you can create. Let's just take a minute and discuss the difference between these 3. External virtual switch. The external virtual switch is the most common type to use for any VMs which need to contact a production network. Each external virtual switch binds to a physical NIC that is installed onto the Hyper-V server. If you click on an external virtual switch, you can see that you have some options for configuring this switch, and that you can even change switch type. In the following screenshot, I renamed my external virtual switch so that it is easier to identify when I decide to add additional NICs to this server in the future. Internal virtual switch. Internal virtual switches are not bound to a physical NIC, so if you create an internal virtual switch and connect a VM to it, that virtual machine will not be able to contact a physical network outside of the Hyper-V server itself, sort of a middleman between the other 2 types of switches. Using an internal virtual switch is useful when you want the VM traffic to remain within the Hyper-V environment, but still provide network connectivity between the VMs and the host itself. In other words, VMs connected to an internal virtual switch will be able to talk to each other and talk to the Hyper-V server, but not beyond. Private virtual switch. The private virtual switch is just what the name implies. VMs plugged into the same private virtual switch can communicate with each other, but not beyond. Even the Hyper-V host server does not have network connectivity to a private virtual switch. Test labs are a great example for a use case for private virtual switches, which we will discuss immediately following this text. When we create a new virtual switch of our own, creating a new virtual switch. Here's an example I often use. I am running this Hyper-V server, which is connected physically to my corporate network, so I can spin up new VMs, connect them to my external virtual switch, and have them communicate directly to the corp network. This allows me to domain join them and interact with them like I would any server on my network. But maybe I need to have the need to create some VMs that I want to be able to talk to with each other, but I do not want them to be able to communicate with my production network. A good example of this scenario in the real world is when building a test lab. In fact, I'm talking this exact approach for all my servers. So I'm taking this exact approach for all my servers that we have used throughout this book. My physical Hyper-V server is on my production network, yet my entire Contoso network and all of the VMs running within it are on their own separate network, which is completely segregated from my real network. I did this by creating a new private virtual switch. Remember from the description that when you plug VMs into this kind of switch, they can communicate with other VMs that are plugged into the same virtual switch, but they cannot communicate beyond that switch. Inside the virtual switch, all I have to do is choose the kind of virtual switch that I want to create, private in this case, and click on that Create Virtual Switch button. I can then provide a name for my new switch, and I am immediately able to connect VMs to this switch. You can see in the following screenshot that I've also created two new private virtual machines, one to plug my test lab VM's internal NICs into, and another switch that will act as my test lab's DMZ network. Implementing a new virtual server. Now we are ready to spin up our first virtual server. Similar to creating new virtual switches, the process for creating a new VM is fairly straightforward, but there are some steps along the way that might need some explanation if you haven't been through this process before. We start in the same management interface from which we do everything in the Hyper-V world. Open up Hyper-V Manager, right-click on the name of your Hyper-V server, navigate to New Virtual Machine to launch Wizard. The first screen where we need to make some decisions is specify name and location. Create a name for your new VM that is easy enough, but then you also have the chance to store your VM in a new location. If you set a good default location for your virtual machines during Hyper-V role installation, chances are that you won't have to modify this field. But in my case, I choose the default option when I installed the role. So it was going to place my VM somewhere in C:\users, and I didn't like the look of that. So I selected this box and chose the location that I like for my VM. You can see that I'm using a dedicated disk for storing my virtual machines, which is a general good practice. Next, you have to decide whether you're creating a generation 1 or generation 2 virtual machine. We don't need to discuss this in very much detail because explanations of the two are clearly stated on this page. If your VM is going to be running an older operating system, should likely go with Gen 1 to ensure compatibility. Now define how much memory you want to assign to this particular VM. Keep in mind that this is a setting that you can change in the future on this server, so you don't have to plan too hard for this. The amount of RAM you decide to this virtual machine will depend upon how much RAM you have available in the Hyper-V host system and upon how much memory is required to run whatever roles and services you plan to install on this VM. You can specify any amount of memory in this field. For example, if I wanted roughly 2 gig, I could type in 2000 MB. However, what I find in the field is that most people still stick with the actual amount of MB because this is what we have always done with hardware. So instead of rounding to 2000, I'm going to set my 2 GB VM to an actual 2 GB or 2048 MB, leaving the box unchecked for dynamic memory means that Hyper-V will dedicate an actual 2048 MB of RAM to this specific VM, whether the VM is using 2048 MB or 256 MB at any given time. The full 2048 MB will be dedicated to the VM and will be unusable by the rest of the Hyper-V server. If you select that box for use dynamic memory for this virtual machine, then the VM only takes away from the Hyper-V host that it is actually using. If you set it to 2048 MB, but the VM is sitting idle and only consuming 256 MB, it'll only be taxing Hyper-V with a 256 MB load. Configure networking. In the next screen we are presented with, and here we are simply choosing which virtual switch or VM's NIC gets plugged into. We do have the ability to add additional NICs to this VM later, but for now we get a standard single NIC during the creation of our new VM, and we just need to choose where it needs to be connected. For the time being, this new web server I am building will be connected to my test lab's internal corporate network so that I can build my web app and test it out before introducing it into a real production network. If I drop down the list of available connections here, you will see that my original external virtual switch, as well as my 2 new private virtual switches that I created, are available to choose from. A few details are also needed so that this new virtual machine can have a hard drive. Most commonly, you will utilize the top option here so that the new VM gets a brand new hard drive. There are also options for using an existing virtual hard disk if you are booting from an existing file, or attach a disk later if you aren't prepared yet to make this decision. We are going to allow the wizard to generate a brand new virtual hard disk, and the default size is 127 GB. I can set this to whatever I want, but it is important to know that this does not consume the full 127 GB of space. The disk size will only be as big as what is actually being used on the disk, so only a fraction of that 127 GB. I mentioned this to point out that number to you. Specify here is more of a maximum size, so make sure your disks appropriately specify enough size that you and your applications have the necessary room to grow. Our last screen of options is the wizard allows us to define specifics on what operating system our new VM is going to run, or rather where that operating system will be installed from. We are going to purposely leave this set to install an operating system later, because that is the default option, and that will give us a chance to see what happens when you do not specify any actual settings on this screen. Starting and connecting to the VM, we have now created a virtual machine, which you can see inside the Hyper-V Manager console. Starting the VM is as simple as right-clicking on it and then selecting Start. After selecting the option to start the VM, right-click on it again and click on Connect. This will open a console window from which you can watch the boot process of your new server. Now that our new VM has started, we can expect to see inside the console: a boot failure, of course. Installing the operating system, we get a boot failure message because we didn't specify any operating system media during our wizard. And so Hyper-V has created our VM and created our new hard disk. But just like when you build a new server out of fresh hardware, you need software to be installed onto that hard disk in order for it to do something. Locally installing an operating system onto a VM is just as easy as installing it onto a physical server. Head back into the Hyper-V Manager console, right-click on the name of your VM, go to Settings. Inside Settings, you will see this VM has a DVD drive automatically listed in IDE Controller 1. If you click on DVD drive, you can easily tell it to mount any ISO to that drive. Copy the ISO file of the operating system installer you wish to run onto the hard drive of your Hyper-V server. I typically place all my ISOs inside a dedicated folder called ISOs, right along my VMs folder, and then browse to it from this section. Connecting an ISO to your VM is the same as if you're plugging a physical installation DVD into a physical server. After mounting the media, restart the VM and you will see that the operating system installer kicks off automatically. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.